In this software testing best practices presentation, Todd Little, the Senior Development Manager with the Landmark Software Services Division of Halliburton, will discuss the challenges of large-scale test automation in an Agile environment and how Halliburton was able to improve results using action-based testing and the TestArchitect test automation tool from LogiGear. Following Todd's case study, we will give more details on the action-based test method and test automation with TestArchitect. Landmark Graphics is a premier provider of software to the upstream oil and gas industry. Their software helps geoscientists and engineers make highly complex business decisions using a next-generation reservoir simulation software suite.
So that's just a little bit of background of the application suite and what we're doing. There's a number of computational challenges. We're solving some fairly complex equations and solving them. We discretize, create models of the Earth and simulate that 30 or 100 years out into the future. So it can be very computationally intensive. We're solving very large models, upwards of millions of cells potentially, which creates a very challenging and computational problem, which is why we use high-performance computing. The great thing about high-performance computing is that there's a lot of power. We can make use of multiple cores and generate results. The challenges are that the more computation power we have available, the more complex engineers tend to make their models. So many of our simulations that we do can take hours. We've even had cases where the really complicated models, we had one of our engineers say he measured the time of his simulation in haircuts because when his job was done, it was about time to get a new haircut. So these are very complicated models that we have to have challenges with, and that's one of our testing challenges is the fact that we do have to figure out, do we test the fully complicated model, or do we create some smaller test cases that test out the similar types of problems. One of our testing problems is that in order to handle our applications, many of our testers are specialists in the area. They're petroleum engineers. They're not test automation specialists. And so that was one of our challenges that we faced all along. We've been in this for a long time, and we've been doing it for a long time. When we're trying to do the right things all along, developers are doing, having some good practices in terms of creating automation tests. But even with that, we were still struggling to get product out the door with high quality. Another challenge that we have with numerical simulation is that we rely heavily on approximations. We do not solve things exactly. We work on approximation. And because we're based on approximation and because we have round-off possibilities or perturbation differences, it does create another testing challenge in that we can make a small tweak to an algorithm and have an equally valid result, but it would not necessarily match a prior testing run. So we have to have some intelligence built in to determine whether the change that we made is a valid change, even though it won't exactly match the baseline test results. We have been doing development within an Agile environment, standard Agile Scrum approach of creating typically on this particular scenario we had a couple different teams that were connected, and each one of them had a slightly different release cadence or iteration cadence, ranging between 1 week. We had one team that was very new and was working with 1 week iterations, which was working out very well. We had a more mature part of the product line working on 3 week iterations, and that was working out very well for them. I think the key part that I find with, I've been involved in the Agile community for quite some time, involved in organizing the Agile conferences and communicating with a lot of the large-scale Agile community. I think one of the challenges a lot of Agile teams have is getting to that potentially shippable product increment on a regular basis. And we were no different. We had a consistent flow through our development process. We were delivering features, and we were testing along the way. but really getting to the point where we felt that we had truly potentially shippable product increments at the end of each iteration was still being a challenge. Our testing, our automation testing that we did have in place was good, but it wasn't catching as many things as we were really felt like we were needing to catch. Many of the things we had developers who were creating a very good unit, a test at a more of a unit level, but because of the nature of the complexity of reservoir simulation, we weren't finding some of the harder bugs until we ran our larger customer regression suite. And when we ran that customer regression suite, it would take us often up to a week to get the results because of the complexity of those simulations. And given that it takes us a week to run those, the delay in getting feedback to the team and getting that fixed was a real challenge. So one of the things we wanted to look at was where some of those gaps were at within our development and testing process. So I think a key part of understanding your flow through the system is really developing a testing and automation strategy. And we laid this model out looking at sort of our complexity of our tests that we were running and then the overall breadth of coverage that those tests were capturing. And we had, at the baseline of this, we had 3 particular areas that we had ongoing. Every check-in, we had a very good collection of developer regression tests. Developers would run that to make sure that what they were checking in was actually not going to break anything, or if it was breaking anything, that it was breaking things in a manner that was still within the engineering accuracy that we were expecting. So they would run the tests and validate them. Very good discipline on the team in having a pretty good high coverage of suites, but not necessarily complex. So these were catching a lot of good things. It was a really disciplined model, but it wasn't catching all the complex things. We had a number of, in the middle upper, we see the customer models. These were quite complex. These were creating some very complicated numerical problems that were typical challenges challenges that we face within high performance computing and round off challenges. These models were ones that were they're very complex, run a long time, and we were only able to run these weekly. So, but they were finding some really challenging, really difficult bugs to find and really sometimes track down. So we discovered that they were great, that we had them, and we had it set up, and we were growing more of them. But it was a gap between the two. And then the other one, we had a very good discipline of running an overall smoke test that we had one of our outsourcing partners was running, and they would run that nightly. After the build, they would run, and actually they would run it during their daytime, and the results came back to us, and by the morning we knew whether the test had passed. So an overall reasonably good test coverage suite, but there were still gaps. And so if we look at where those gaps were, the one was the gap between the developer tests and the customer models. We said what we really needed was to have something that would mimic the customer models but could run more frequently. We wanted something we could run nightly that would cover that. So it's a bit of test case design. We said we need to create that. The other thing, the other gap we looked at was we were doing these smoke tests manually, and we thought this is something they're great that we do them, but we'd really like to look at doing that more automated, because we were requiring the use of some fairly valuable petroleum engineering resources that we could be having do something else. So we looked at what we could do to automate our smoke tests. So with that, then we introduced 2 new areas that we added to our overall testing suite. We had this, what we called the mid-tier tests, which were still fairly broad coverage, but had an increasing complexity, would start to mimic some of the challenges that we were seeing showing up only within the customer model. That was a huge success for us, to be able to have that additional level of testing filter that would tell us more quickly, and developers could act on that very quickly, and therefore improve our ability to get to potentially shippable faster. The other thing we did is we put on a program to automate the smoke test, the GUI level smoke test, and that was a program where we worked with LogiGear as a partner. And one of the things we were able to do as a result of that is because we had the manual test, and we were now converting manual effort into more automated effort, we could actually increase both the breadth of coverage and to some extent the complexity of those tests. So we not only converted them from manual to automated, but we actually increased our coverage and at the same time. So that was another big win for us. If we look at sort of how this was set up, our core base development activity is in Houston, Texas, where the team's about 15 developers. Of our testers, we had 6 petroleum engineering testers in the Houston area. We had 2 project managers that were coordinating some of the cross-team activities because these development teams were broken up into multiple teams, and 2 product managers which were guiding the team at the time. We were working with 2 outsourcing partners, one outsourcing partner in Bucharest, Romania. That was a particular center of excellence for us in that they were able to provide us with developers and petroleum engineering testers. So we were able to find a partner that understood our particular area. There's a small little group of, headed by a petroleum engineering professor at the local university in that area, and he created a software company and was able to train developers and petroleum engineering testers that really understood our software, and we could leverage that partnership quite well. And then we worked with LogiGear based in Ho Chi Minh City in Vietnam. And we really selected LogiGear on the basis of their particular expertise in GUI level automation. We were aware of some of what they did and some of their testing methodologies, and we thought that things such as action-based testing that we'll be going into a deeper dive later was something that really fit well. We had tried to do GUI level automation in the past and not been very successful at keeping the test from being too brittle, and we thought that with their knowledge and expertise that we would be willing to give that a shot, and we thought that worked out quite well. So we get a little bit of history, a little bit of a timeline here of our overall testing strategy, and if we look at the y-axis here, we're saying test complexity. Think of this in terms of how much compute time we were really utilizing in automation testing, and so over time we really took on an activity of effort to increase the amount of test automation and reliance on more compute time to do that testing than man time, and that was as we were running out of. We didn't have enough people available, but we could make more hardware available to push through more testing, and that increase in coverage was critical. Look at the overall test automation workflow, fairly standard. We had some data input. We had some actions that we take on that, which is in this case to simulate the results of things. That generates some output, which we then had to work through with a difference engine to determine relative to a baseline, have we had any changes in the regressions, and then that produced a report. And there's basically 2 automation structures that we had in place. One which was our own activity that we were testing under the GUI, and in that one we really were testing heavily on the simulation engine. And then there was the work that we were doing with LogiGear on the GUI level, and in that case we were really structured within the TestArchitect application within that LogiGear is utilizing. So on the GUI level test automation, there's really 2 approaches that are fairly common. One is what's called record playback test automation, where the test cases are played out by some testing engineer. The tests are recorded along the way, and then later they're played back, and hopefully the purpose is to find that you get the same results when you do the playback. This model is one that's fairly common. It's relatively simple to start implementing. So if we look at it in the cost versus number of test automation, it's pretty much linear. There's not an upfront start cost, and but the thing that's important is that there's the cost to maintain these can get very high, because it's very easy to break how the record mechanism, what the record mechanism recorded if you make changes to the GUI or the application. So these can be quite brittle. I think that what we really liked about LogiGear's approach is the action-based testing methodology, where the test cases are broken down into a number of test actions, and then these actions are reusable across, to the extent that they're similar across multiple workflows. Those actions can be reused and build up test cases and test suites from those actions. So there's an upfront cost associated with that test design and building up of those actions, but over time, as you see from the cost to generate goes down as you have a number of actions that you can reutilize. And the key part, probably even more important, is that the total cost to maintain goes down substantially as these become less brittle. If one area of the application changes, we only need to update the action associated with that area, and then every test that reutilizes that action is fixed as a result. So there's a very substantial gaining on software maintenance, of the test case maintenance. Look, Joe will go into a little bit deeper dive on action-based testing, but this is just a little bit of a setup on why we went with LogiGear for this approach. Getting back to our approach, this combined effort of increasing our test coverage and working with LogiGear to have more automation testing at the GUI was really a huge help in getting us towards a model where we had truly potential shippable product increment. We had a focused effort on keeping our quality issues under control and getting to a point where we were in a potentially shippable. Once we did this release was vastly different than prior releases. In prior releases, we were always feeling like we were in a frantic mode, trying to get the software out the door and always chasing those last bugs. With this release, once we had this approach in place, it was just like, oh, it's time to ship, and we shipped. It was really just a very, very different environment because we had our acting under control and our quality under control. So if we look at the bottom line, between the years of 2009 and 2010, in 2009 we had a big effort. We thought we were doing a good job, but when we rolled out to beta, we found 222 defects in the beta time, and it's a fairly extensive beta program, so it went on for a long time. But because we found that much, we were really only able to reduce down to about 104. We still shipped at the end with 104 issues, and that was it was acceptable. We felt it was still a valid product. The issues we had to do triage and said, well, they're not critical. There's still a huge amount of value from the product, but we wanted to do better, and that's what the change was. In 2010, we had we only found 36 defects in the beta program, and that was huge because we were able to then handle almost all of those defects. We still shipped with about 3 known issues, which were marginal, really, even as to whether they were truly issues or not. They were too risky to do anything about, and they were very, very, very low priority issues. So we felt really good about the fact that we were able to get our quality under control through this overall approach. Net result is about a 97% reduction in the known issues that we had at ship. This is one particular application suite within Landmark. This and other projects, initial projects, led to even more partnership with LogiGear. So I wanted to go through a little bit. We've got overall within Halliburton about 23 projects engaged, 76 test automation engineers. We've automated 11,018 test cases as of some stats we did before. I think the key part, though, is we're feeling like this automation approach is a real strong leveraged investment. We think somewhere around, for every investment that we make in a test automation engineer, we're getting about 3 times the coverage that we would get from. It would take us three manual testers to get that same coverage. So this automation is key to get to expand our coverage, and also really to get coverage we couldn't get otherwise. That's all very, very important. One of the things that this leverage does is it takes us from having a prior model where we have a lot of manual testers to one where we can invest in some automation, and then the reduction that we have gives the manual testers that ability to spend more time in exploratory testing. And that exploratory testing is truly critical. An overall testing strategy needs to include automation at all levels, and it also needs to what we find is that in particular an application like ours, where it's very, very complex, it really needs that deep understanding of the technical expert, the petroleum engineer that knows how they're going to use it. We need that human interface to look at and actually go digging for problems that we just can't find in an automation. The automation is there to protect us and to give us understanding that we really have not regressed. The exploration testing is there to say, what could another end user of this find that we really didn't even anticipate? And so freeing up the times for our engineers to do more exploratory testing, I think, was another key element of this overall strategy. Some of the quick challenges that we faced, one of them is that we're in a very sensitive industry with deal with a lot of customers that have data that's very critical and proprietary. That those customer data sets are, our customers grant permission to Halliburton to utilize those data sets for the purposes of testing. That extent does not necessarily extend to our outsourcing partners. So some of the things we had to do there was, in particular, as we're developing some of our mid-tier test cases and some of our other test cases, is it forces us to rely on synthetic data that simulates some of the challenges that we are seeing in the real customer data, but does not infringe on the proprietary nature of that customer data. So a little extra work. It would be nice if we didn't have to do. We felt like it was something that we could work with fairly well. A lot of times with outsourcing, there's a challenge of time shift. In our case, we had a distributed team that had three locations: Houston, Bucharest, and Vietnam. Bucharest being 8 hours ahead of Houston, and Vietnam being a full 12 hours. Certainly there are challenges associated with that. It's also an element you have to understand, well, what can you do to help? If you look at the overall global picture of what's going on in the big picture, you need to look. We looked at, well, what could we do to globally, look at this as an overall system? Could we improve things? One of the things we ended up doing was shifting our build times so that by the time the nightly build had completed, that we could then go ahead and run the automation tests on that. So the transfers and file transfers and automation necessary to ship electronic things and then get results back worked out really well, because then we could actually work a model where the automation tests were run by the team in Vietnam during the nighttime. They would be evaluated first by the team in Vietnam, and then they'd be work with our petroleum engineering team in Romania, who would have a chance to look at any of the more detailed petroleum engineering issues that might show up and validate whether, in fact, they were artificial issues or whether they were true issues. And then by that time, and by the morning in Houston, we had confirmation as to whether the build from the prior day was valid or not. So we were, in this case, we're actually able to work out a model which effectively followed the sun. It's a matter, I think, of little bit of serendipity in how the time flowed, but it was also a bit of looking at how the lay of the land was and trying to utilize it to our advantage rather than being a victim of it. Some of the key takeaways, I think, is one of the most with Agile development is to find and correct defects early in order to reduce uncertainty. The uncertainty associated with defects is much greater than the uncertainty associated with features, and we seem to all want to live a lie and develop features fast and think we're going to solve a problem by making it up in testing later. It never seems to work. So my view is get the product to a solid state and keep it there, and certainly that helps with your overall predictability. Having a testing strategy is key to being able to help maximize efficiency. Automation is key. It's key to being able to maintain the velocity. We believe we've been working with outsourcing teams for over 10 years, and we believe that it can work, but it has to be takes effort to make it work, and use it as appropriate. Especially need to treat your outsourcer as a partner. We've been working with LogiGear and definitely feel like they're a partner with us. If you do that right, you can get very cost-effective global talent. It was not just cost-effective, but in this case, LogiGear was bringing talent which we did not have that readily available. Distributed teams can be effective if you take the effort to make it work. Test automation does not replace exploratory testing. You still need the value of that human mind to look at some of the complex scenarios that automation can't find. And automation is really not the place where you're finding bugs. Automation is there to help make sure you don't regress. Exploratory testing and other manual testing is still critical to hunt down and find the most challenging issues. And then lastly, it's to the extent of automation, the approach of action-based testing does help to reduce the test brittleness and improve the overall maintainability of the automation test. So with that, I will turn it back over to Joe to go through a deeper dive on action-based testing.
All right, well, thank you very much for that, Todd. What we'll do now is go through how TestArchitect, the test automation tool that we've supplied to Halliburton, can help anyone achieve large-scale test automation. My name is Joe Luthi. I am Marketing Director at LogiGear. We've been using TestArchitect quite a while to supplement our own internal testing services. As you heard Todd say, we've had a lot of testing services that we do testing for companies, and we employed the action-based testing methodology, and then we developed a tool to go along with that, really, number one, to make our own internal teams more effective, and then we actually productized this and made it available for all customers to be able to speed up their test automation and also achieve large-scale test automation. Especially in an agile testing environment, you have a lot of testing challenges. You go through the manual exploratory testing, and you do a number of these with each sprint, so every change requires manual exploratory testing. But then with each sprint, as you start to do more and more sprints, your regression testing requirements also increase. What happens over time is you start to increase your sprints, your regression testing soon becomes very significant, and then a lot of companies, and like Todd experienced, your total testing capacity gets stressed. So your options are increased testing resources, and it's hard to really maintain that in a budgetary sense just by throwing people at it. That pretty soon runs up against a lot of resource constraints. So the other option then is to slow your release cycles, or just limit the testing coverage you do, and that's going to lead to a lot of undiscovered defects at shipment. What we've found is always the best approach is just change how you do things, and that's where action-based testing comes in, and we like to think of this as a very efficient modular development approach. Action-based testing takes keywords really to a new level. We do this really by starting it backwards. We look at test plan development and test design. And as Todd alluded to, there's a little bit of a learning curve that goes into this because it's a different way of thinking about things. You really efficiently organize your tests into different modules, and within that module you can have a number of test cases that you run, a number of tests, but it's very succinct, and you develop these modules based upon what you want to test. That in turn is going to depend upon the keywords that turn into the actions that you develop. Rather than just starting to make a whole bunch of keywords for all these tests, the test plan development really makes it very efficient in how you develop your actions. You save those in the library, you associate your interface definitions with those, and then once you run the test, those tests and actions are all combined in the TestArchitect automation engine. This makes it very efficient, and the big benefit here is that the actions and the interfaces are all separate from your underlying code, so that whenever you go in and make a change to an action, it updates all the way across. You don't have to rewrite a lot of code, and that makes your tests much more maintainable. So that's the overall design, and then we get into the action-based, where we develop the keyword actions, and again we like to think of this as a modular test design. The low-level actions are what we call like a mouse click. Could be an entry box, it could be to select a product. These are all called low-level actions, and you can go in, you can use these low-level actions to create test cases. The beauty of the modular-based design is that you can create all these individual test cases, but then you can combine them into an action, so that your automation engineer can combine a number of these actions. They can create their own specific ones. They can combine them to make a high-level action that's identified by a keyword. So for instance, you could do a develop an action that would actually go through a checkout process to where you identified your product, you click that's the one you wanted, and you click checkout, and that would be an action in itself that a number of those tasks combine. You can also combine these higher level actions with low level actions and other higher level actions to make even higher level actions. That could be a whole test sequence, that could be your whole order entry process. That would be one action that is automated, so that whenever you have your tester goes in and it's a highly repetitive or it's regression, rather than creating all the steps, they could just create one and implement that action, so it really speeds the test development, so it increases your time. It decreases the time you need to take to create your tests. But the big part of it is really the maintainability, and you know, as anyone that's been around testing for a while knows, there's a lot of automation tools that allow you to get up to speed very quickly on creating a lot of tests, but as Todd alluded to, the maintenance cost gets very, very high. With the keyword actions, and these are all in an action library within TestArchitect, you can go in and you can make a global update to a very large test whenever any number of actions change, just by going in, modifying those actions, save them in the library, and then every action that is impacted throughout that test will be automatically updated when the tests are executed. So this is where it really becomes cost effective from a maintenance standpoint, being able to update all your test routines very, very quickly. Now, putting it all together, and you know, that's kind of conceptually how it works, but here's how it's actually laid out within TestArchitect. This is a partial screenshot that actually shows a test module that you'd create. And in the way it's laid out over on your left-hand panel is you would have a test made up of a series of test modules. And those test modules are all developed from your actions, and there's a significant library of actions that come pre-programmed, but then your automation engineers can use domain-specific language to create actions that are specific to your applications and save those in the library that can be reused over and over again. They can be checked out by globally distributed teams to use to combine tests. Here you can see that all of the actions in the action library, most of them have a plus mark next to them. That means they can be expanded. They're actually made up of additional actions that are packaged into one to make test creation very, very quick. And then you have your interface definitions. Again, they're separated from the actions, so each action that applies to an interface that has actually gone in, tagged to that, and it'll be updated whenever the test is run. To create a test using actions is, this is what very similar to the screen that Halliburton uses. You go in and you have your selection tree on the left-hand side that shows all of your test cases, and it shows all of your actions. And then you would actually create the test case from the actions you can do it by drag and drop, or you can do it by predictive text. You start typing the action you want, and it'll come up with an auto-population list that you can select from. So it eliminates the typing you need. Once you drop in the action, all the criteria that will be used as argument will pop up for that action that you put in your argument criteria. And you could also use this for data-driven testing, where you could have a database that pulled that information from. So the test module layout, as you can see on the main screen, you actually have your objectives that define exactly what is going to be accomplished within this test module. And then each test objective has a test case with it that identifies exactly what steps are undertaken in that test case. There's also an initial part of the program. An action is actually used to log in so you can start to run your test. It's not part of the test, so it's just used to log on so your test can run. Your test case runs, and then the final action will be a cleanup to close out your test and then do your report. So this is a very efficient way to create and design tests using a very simple input screen that's as flexible as you need it to be. So ABT in Agile, this is kind of the workflow that we'll see. The product owner takes on the product backlog, and that's where the test module definitions come in. So you define your modules there, what modules you want. Then that gets handed off to the team when they do their sprint, where you develop the actual test modules. You outline your interface definitions. Any actions that you need an automation engineer to create specifically for that sprint can be created, and then you run your test. And then in the next step, you pass it off to the product owner and the team, and once the product is out, they can reuse the test cases and reuse the automation to run all the regression tests they need whenever things change or the next sprint comes out, to validate that everything is still working the way it should. So, the bottom line that we've been able to do, and it's been what we've been talking about TestArchitect for a long time, and really what Todd's experience at Halliburton indicates, is that TestArchitect is able to give you a significant reduction in testing resources. You can increase the test coverage, and a big part of what we all do is we want to improve our product quality. And so combining that all together, it allows you to come out with a higher quality product with less time, less cost, and meet your deadlines. So that is our presentation today on TestArchitect and the case study. We hope you enjoyed it. We would certainly be glad to hear from you. If you would like more information, here's the information you can take down.